Hello, Christine Halsey here, and today we're going to look at solving parallel branch currents. This is Lab 2 in the parallel circuits. The supply in a parallel circuit is connected to each branch electronically, and Kirchhoff's current law tells us that the sum of the currents coming in and going out of a node should equal 0. So IT minus I1 minus I2 minus I3 should equal 0 in this case. So to solve for the total current, if we can find the current branch 1, the current branch 2, and the current branch 3, we can add those together for the total current. Here's another example. If we have 3 branches with 10 milliamps, 20 milliamps, and 40 milliamps, we have a total of 70 milliamps. The voltage is the same at each branch since the supply is connected electrically to each branch. If we're given a supply voltage and known resistor values, we can then calculate each of the branch currents using Ohm's law. I equals V over R. Here the voltage is 10 volts and 1K for 10 milliamps. With 560 ohms, we get 18.86 milliamps. And with 470 ohms, we get 21.23 milliamps. Okay, so here's my circuit in Multisim, and I took it and set it up to measure the voltage drop across the supply and each resistor, and you can see they're all at 10 volts. After going back, I found I had a number wrong. It should be 17.86 milliamps, not 18.86 milliamps. And we verify that here in Multisim. So I have my 10 milliamps, 17.86, 21.3 for a total of 49.134. We have a little rounding differences, not a big deal. I replaced their meter that they had in here with this one because it gives me more accuracy here. Notice each of the meters is set to read current. Our hardware portion is next, and I think the instructions said to change the 470 to a 220, but since we've done all the calculations here with the 470, I'm going to use the 470 instead of 220. Okay, my first step here is to make sure all of my resistors are in parallel. I don't have to use these jumper wires here, but I have to make measuring the current easier. Next, I'm going to use the variable 12 volt plus here and ground to set my 10 volt supply. Okay, so I have my leads in the plus 12 and ground. I've turned on my power supply. Don't have it connected to anything yet but my meter. I'm going to click my meter once to turn it on to volts, and it comes up by default on AC, so we click the button to go with DC. Now it's set at 12 volts, so I'm going to tune it down and adjust it and get it as close to 10 volts as I can. Okay, and after trying to adjust that, I realize I'm in the wrong one. My variable is the 18, so I'll put my ground in the center. And it's been one of those days. Now I can use the knob to adjust as close to 10 volts as I can get. Okay, I've now set up my 10 volts and applied it to my breadboard. Ground down here to the very bottom and power here. And I have my meter leads set up to measure the applied voltage, and just since I set it, it came up. Ooh. if I come to across each resistor, I should see the same 10 volts. Oops, I wasn't in the right row. There we go. And if you're not in the right row with the resistors and the wire, like I was a minute ago, then you don't get the right reading. If I come here and try to make the reading, or here and try to make the reading, it's not reading correctly. Alright, so but all of our voltages are reading right at 10 volts. Okay, to begin reading my branch currents, I'm going to turn off my power supply. I turn off my meter. I need to make a break in the branch, so I'm going to start with R1, and I'm going to pull one of his legs up and move it over to a row, creating an open. Alright, now to make the measurement, I'm going to complete that open with my meter. Alright, so I have an open that I've created, and now my leads are in the corresponding holes to connect those 2 points using the meter as the connector. So now the current's going through the meter. Alright, I'm going to turn my meter to the milliamps. I'm going to check and see if it's in DC mode. Mine is. If yours isn't, hit the select button to turn it into DC mode. Then I'm going to turn on my power. And figure out what I did wrong. I did wrong what you probably did wrong, because I didn't tell you to do it. I need to move this back to milliamp. And if I'd have done it the other way, I'd have just blown the fuse in my meter. So, alright, there's my 10 milliamps for the 1K branch. I'm now going to fill that break in, create one in the next branch, and fill it in with my leads. Turn the power off before making your next break and completing the circuit with the meter. You see, this is my 560 branch, or green, blue, brown. And I'm getting 17.73. I think we had calculated 17.8. That's perfectly acceptable. And for my last break with the 470, yellow, violet, brown, and 21.5556 milliamps. Now, to measure my total current, I've actually made the break here where I connected the power supply in, and I put my red lead here where power was coming from, and ground down here where it was going to. I'll turn on my power, and there's 49.2 milliamps, 3. Great, we're right on target. Any fluctuations like that are due to real life variables. Nothing's going to come out as calculated. If it does, take a picture and a video of it, because very rarely does it come out 100% perfect.